atomic bonding and correlates with chapter 6.1 in your textbook. Your key concepts for this video are: what determines an element's chemistry? How do you determine the number of valence electrons? And what causes chemical bonds? So when we're talking about an element's chemistry, we're talking about its properties. And you know, one thing that we've talked a lot about is an element's reactivity, its ability to react with things. And you know from your previous video that your alkali metals here in group 1, these are the most reactive of the metals. We also know from the last video that our halogens here in group 17 are the most reactive of our nonmetals. But what makes them so reactive? Well, this has something to do with their valence electrons. A valence electron is simply the electrons that are found on the outside orbital or shell of an atom. They happen to have the highest energy of all the other electrons, so that makes them determine how the atom reacts. Now, this we can look at it and see that there are two valence electrons, but what if we're just looking at the periodic table? When we're looking at the periodic table, we can find the number of valence electrons by looking at the ones place of the group number. So here, this is group 1, the 1 is in the ones place, so it's got 1 valence electron, every single one of these. The ones in group 2 have 2 valence electrons, all the way down. We're going to skip these transition metals, and we go over to group 13. 3 is in the ones place, so there are 3 valence electrons for all of these elements. Group 14 has 4. Group 15 has 5. 16 has 6. 17 has 7. And 18, for the most part, has 8. But remember that first electron shell can only hold 2 electrons. So this just means it has a full electron shell. So helium technically only has 2, but it's still a full valence shell. Now, we skipped these transition metals because a lot of these have varying numbers of valence electrons. So to find it out, you'd look on a chart, or if you were looking at the chemical formulas, it would be written in Roman numerals behind it. So to see this visually, you've got group 1, so 1 valence electron. Here we've got hydrogen, lithium, and potassium, all with 1 valence electron. Group 14, we look in this ones place. We've got 4 for carbon, we've got 4 for silicon, and we have 4 for germanium. So even though there's all these other electrons in here, the only ones we're paying attention to are these outer rings. And then our group 18, we've got a full valence shell for neon with our 8. And we've got our full valence shell for argon, again with our 8. And remember, helium, that first shell, it's a full shell because it's got the 2, but it's only got 2 valence electrons. Now, this is a lot of work to draw if we're only paying attention to the outside electrons. So, we have a shortcut called a Lewis dot diagram. And this is simply a way to represent the valence electrons of an element. So what you do is you write the chemical symbol, and then you would put 1 dot for each valence electron. So lithium is in group 1, it has 1 valence electron. Beryllium is in group 2, it has 2 valence electrons. Boron's in group 13, it has 3. Carbon's in group 14, it has 4. Now nitrogen is in group 15, it has 5 valence electrons. You might have noticed that I'm putting each electron on its own side. That's because just like when you get on a bus, if you don't know nobody on the bus, you don't want to share seats, you just want the whole seat to yourself. Electrons are similar. They want as much space as they can possibly have. So they're going to fill each side on their own. They don't want to pair up if they don't have to. But we ran out of space and there's a 5th electron. So that 5th electron gets on the bus and sees, all the individual spots are taken. Fine, I guess I'll pair up with this one. And so then they share a seat. Oxygen has 6 valence electrons because it's in group 16, so that 2 of them will have to pair up. Fluorine's in group 17, so we get those 7 valence electrons. And then neon is in group 18, and it gets those 8 valence electrons. And yes, you might notice I'm doing them around and doing them one at a time. This is what you should do. That way you're not accidentally pairing things up that you don't want to. Now, atoms want to have a full valence shell. They want that full valence shell. So one way they can do this is metals will give electrons to nonmetals. So lithium has 1 valence electron. It either wants 8 around it or it wants to be dropped down to the next orbital. So it gives up its electron to fluorine. So then fluorine gets full shell and lithium is a full shell. This gives them a slightly positive and negative charge, which creates ions, and we'll be talking about that soon. Now nonmetals, because they're both so close to having a full valence shell, hydrogen just needs one more, oxygen just needs one more. Instead of giving one up, they share. And so they share their electrons with each other. And that is what causes these chemical bonds. They're simply the force of attraction together due to the rearrangement between electrons. So NaCl, sodium chloride, salt. Sodium gives up its electron to chlorine. That way, it has a full valence shell here, and this one has a full valence shell here. And then that makes them attract together. Whereas Cl2, or chloride, that bonds together, and it shares each one electron, because they both needed one electron, so they share it and get a full valence shell that way. That's it. Be sure your notes hit all the key concepts and vocabulary, and feel free to try this challenge question.